Hello everyone, welcome to Augmentech. We coach engineering students and working professionals for better career opportunities. In this tutorial, we'll study about the COP of refrigeration cycles. To understand about COP, let us understand a situation where there is a cold reservoir. For example, the inside of a refrigerator can be considered as a cold reservoir. This is at low temperature. We need to remove heat from this cold reservoir, so we need to use a device called refrigerator. Once we supply work to the refrigerator, it starts extracting heat from the cold reservoir. This heat is now dumped into the hot reservoir. In this process, heat is being taken from a body at low temperature to a body at high temperature. This is the reason we are using an external device. If we were to supply heat from the body at high temperature to the body at low temperature, there is no such use of any external device. But because we are going opposite to a natural process, we need to use a device called refrigerator that takes the heat from the body at low temperature to the body at high temperature. In our situation, we can consider the outside of the refrigerator to be the hot reservoir. Now we are in a position to define COP, which stands for coefficient of performance. It is the ratio of heat removed from the cold reservoir, which is inside the refrigerator, to the work done to remove the heat, which is the work done by compressor. The ratio of these two quantities is known as coefficient of performance of a refrigerator. Higher the value of COP, better the performance of refrigeration cycle. Superheating. Let's say there is a sample of water at 80 degrees centigrade. Its boiling point temperature is assumed to be 100 degrees centigrade. On heating this sample of water, its temperature increases. On further heating this water above its boiling point, it obtains a temperature of, let's say, 120 degrees centigrade. When water is heated above its boiling point, this process is called superheating. So any substance heated above its boiling point is called superheating. Superheating is above the boiling point. It ensures complete conversion of liquid refrigerant into vapor. It is done in evaporator. As already discussed, in evaporator, heat is extracted from the room or conditioned space. This heat converts the liquid refrigerant into vapor. It is done to protect the compressor because even small amount of liquid refrigerant can damage the compressor. So the process of superheating is done in evaporator and before the refrigerant enters the compressor. Subcooling. Let's say there's a sample of water at 120 degrees centigrade and boiling point temperature is assumed as 100 degrees centigrade. On simply cooling this down, the process is known as cooling. On further cooling it down to a temperature of, let's say, 80 degrees centigrade, the process is known as subcooling. Therefore, the process of cooling any substance below its boiling point is called subcooling. So subcooling is cooling below the boiling point. It ensures complete conversion of vapor into liquid. It is done in condenser as already discussed. While the refrigerant flows through the condenser coil, it rejects heat, thereby leading to the complete conversion of vapor refrigerant into liquid. It is done before the refrigerant enters the expansion valve to protect the expansion valve.